First, I'd like to apologize. For some reason, my tablet input is not working, so I'm just going to have to use the mouse to draw. So this will be a little bit rougher than normal, but I wanted to make sure I got a video out today because I told you that I tried to do so. So this is the first homework problem for homework number 11. And what it says that there is a disk, and the radius of the disk is 0.8 meters. And you're given omega is equal to 5t, and as you've noted, I like to divide by seconds so that I can have a unitless number there, and then plus 2, and this whole thing then ends up being in radians per second. And what it wants to know is what is the acceleration, that's an A, and the velocity of point A, and it draws a point over here. So I'm going to talk through this like this was a question that's on the test. And so one of the questions that's asked is, what equations would you use to solve this problem? And normally that's one of the more difficult things, just to figure out, well, where in the world am I going to start? So for this, I'd actually start with velocity, because I think that is a little bit easier. So velocity of a point on something that's rotating is v is equal to omega r. Oh, and I forgot to say, they said t is equal to 0.5 seconds. So all we have to do is we just plug our t in here, and that will give us our omega, and we have our r. So with this equation, we can solve for velocity. Now acceleration is a little bit more difficult. So this is pinned in the middle, so it's going around in a circle. And so naturally you should be thinking of normal and tangential components. So I would say the overall acceleration is equal to the normal acceleration squared plus the tangential acceleration squared, and then square rooted. There we go. So then you need to know what are these components. So a sub n, the ones that you've been dealing with in the past, is v squared over rho. But then if you don't know v, which actually we do, but let's pretend that we don't, because we know omega. And so the other equation is omega squared r. And this is just v squared over rho, where v is plugged in. So you end up with omega squared r squared over rho. And so the rho cancels on the bottom, you end up with omega squared r. So this is another equation. And then the last equation that we need, second to last, is that the tangential acceleration is equal to the angular acceleration times r. So the only thing that we don't know here is alpha. We know r, and we're solving for a sub t. So then I would go through, and alpha is equal to d omega over dt. So these are the equations that you would use. So all these would be correct answers. So v equals omega r. The acceleration is equal to the square root of the components. Normal acceleration is equal to omega squared r. Tangential acceleration is alpha r. And alpha is d omega dt. So if we then go through, the next questions that tend to be asked are, so what are the variables? And what do things stand for? So omega, we already talked about, you're going to put 0.5 seconds into t here, and that will solve for it. You end up with 0.5 times 5 and then plus 2, and it's in radians per second. R we already identified as 0.8 meters, and v would be unknown. Then for the acceleration, I normally don't ask this question, but if I did, I would technically say all of these are unknown at this point. the overall acceleration would be the main thing that you're solving for with that equation. But really we don't know any of them at this point, but they wouldn't be hard, so I may ask you to solve for them. The normal acceleration, omega, we already talked about. You plug in the 0.5 seconds to omega to get that. And r, again, is just the 0.8 meters. And the an is unknown. And then for the at equation here, at is definitely unknown. Alpha would be unknown until we solve for it down here. And r, again, is the 0.8. So how do we get alpha? Alpha is d omega dt. Omega is just from our equation up above here. And so when you do d omega dt, if you were asked to solve for that, t goes away. So you're left with 5 and then plus 2. And radians per second. Oops, I made a mistake, and I was just going to go to the units, and that would show me that there was a mistake, so I would end up with units would be per second here. But then I'd be adding 5 per second to 2, and that doesn't work. And that is because I mistook my derivative here. When you take the derivative of a constant like 2, obviously that goes to 0, so this should not be here. So let's redo that. So this is 5, the time goes away, but it's still per second. And then plus 0, because the derivative of 2. And then radians per second, which is the same as 5 radians per second squared. And that's your alpha, so then you could plug that in here. So if I were doing this problem and I was asked what are the unknowns in my tangential acceleration equation, or what is the value for alpha in that, I would look at it and I'd say, well, I don't exactly know it, but it's also very easy to find, so let me check, and if 5 radians per second squared is an answer, then that would be the correct answer for it. So now you have all of the equations and all of the values, so you can solve the problem.